Hi everyone, today we're jumping into a classic physics problem, but we're going to tackle it like we're solving a mystery. We've got a racing car, some key information, and one big question. How far did it go? So let's get into it. All right, so picture this. A sleek racing car sitting at the starting line. Engine's quiet, completely still. The light turns green and it just takes off, accelerating at a steady, constant rate. Our challenge? We need to figure out the exact distance it travels to hit a certain speed. And here is our specific mission. A racing car starts from a dead stop, and it accelerates at a constant 4 meters per second squared. The question we need to answer is, how much road does it cover to reach exactly 20 meters per second? To solve this, our first move is to act like a detective. We're going to carefully examine the problem and pull out every single piece of information it gives us. Let's start gathering our clues. Okay, so the problem statement actually gives us 3 really important clues. First, it says the car starts from rest. In physics speak, that means its initial velocity, which we call u, is 0. Simple enough. Next, it reaches 20 meters per second. Boom! That's our final velocity, v. And finally, it accelerates at 4 meters per second squared. That's our acceleration, a. And just like that, we have all our knowns. So, with those 3 clues laid out, our objective is crystal clear. We need to find that one missing piece of the puzzle, the distance, which, in the world of physics, we represent with the letter S. We've got our clues. Now, every good detective needs the right tool to crack the case. In physics, our trusty tool is almost always the right equation. And for this job, the perfect tool is the third equation of motion. 2as equals v squared minus u squared. Now, why this one? Well, think about it. It directly connects all our clues, A, V, and U, to the one thing we're trying to find, S. And what's really key here is that it doesn't involve time, which is another unknown we don't want to deal with. This makes it the perfect choice to solve this efficiently. All right, we've got our clues lined up, and we've got our special tool ready to go. Now it's time to put it all together and actually solve this puzzle. Let's walk through this together. First, we substitute our values. We just plug our numbers right into the equation. So A is 4, V is 20, and U is 0. Easy. Next, we simplify each side. On the left, 2 times 4 gives us 8, so we have 8s. On the right, 20 squared is 400. That leaves us with a much friendlier equation, 8s equals 400. The last step is to get s all by itself, so we just divide both sides by 8. And with that one final, simple calculation, we've cracked it. We have our answer. The answer is 50. But 50 what? 50 apples? 50 feet? A number on its own doesn't tell the whole story, so let's put it in context. The racing car travels a distance of exactly 50 meters to reach that speed of 20 meters per second. And there we have it. By following a logical step-by-step process, we found a clear, definitive answer. Case closed. So what's the big lesson here? It's really all about the problem-solving strategy. First, you hunt down all your known variables from the problem, your clues. Second, you pick the best tool for the job, the equation that links what you know to what you want to know. And finally, you just plug in your numbers and solve it step by step. This exact same method is a powerhouse for tackling tons of different motion problems. So we figured out the distance, which is awesome. But, solving one mystery often leads to another, doesn't it? We know how far the car went, but we still don't know how long that journey took. Now, that's an interesting question to think about for next time. Thanks for joining me on this one.